Okay, so we are looking at finding an unknown value using matrix. So in this we see happening, we see this in mathematics, we see this in economics, the higher level economics, and we see this in finance, and I believe you may see it in other courses too, or other subjects too. So it's a general thing. Okay, so if you understand it now, if you're in SHS and you are watching, you understand it now, it helps you when you further your education in mathematics, finance, and other fields. If you're in tertiary too, that's okay. So we have two ways of finding the unknown variables, or let's say values of some empty blah blah blah. Okay, so something like, they can give you something like, is it 2, 4, 5, 6, and you have, let's say, x and y, and they say equal to 7, 9. They can ask you to find y. There are two ways that you can, x and y. There are two ways that you can find x and y. You can either solve it simultaneously, or you can use the Cramer's rule. Okay, the Cramer's rule makes use of determinant of a matrix. So you still have to, if you don't understand how to find determinant of a matrix, kindly watch the video on the determinant of a matrix. The simultaneous equation will use multiplication. So what the simultaneous, so we'll do it step by step. So solving this simultaneously, we have to multiply this and equate to this. So when we multiply, you have, so if you know what the video on multiplication of matrix, kindly watch the video. Oh, so we say we bring this one, we turn it to something like this. So it will be 2x plus 4y. Then I'll have 5x plus 6y. Now it's equal to 7, 9. So I have something like this. So it means that the first one takes this, the second one takes this. I have 2x plus 4y equal to 7, and 5x plus 6y is equal to 9. This becomes equation 1, this becomes equation 2. So you can now solve this simultaneously, and even for simultaneous equations, the calculator can help you find simultaneous equations. So when I switch on the calculator, when I go to mode, I'll select equation, which is 5. When I select 5, I'll see 1, 2, 3, 4 different equations. The first one is for simultaneous equation. The second is also simultaneous equation. But the first is for simultaneous equation of only 2 variables, that is x and y. The second is for simultaneous equation of 3 variables, x, y, z. So this one is only x and y. So it means that we are looking at 2 variables. So I'll select the first one. When I select the first one, they give me a table form, 2 rows. So with ABC, the ABC are just the coefficients. So the A is the coefficient of x, and the B is the coefficient of y. The C is the constant, which is the one after the equal sign. So now I can punch, the first one is 2, 4, and 7. So I'll press my 7. And the second one is 5, 6, 9. So I get x to be negative 3 over 4, and I get y to be 17 over 8. So using the calculator, x is negative 3 over 4, then y is 17 over 8. So without the calculator, simultaneous equation, you can use elimination method, you can use substitution method, you can use something like you can also use factorization method, like other means. So with that one, there is no video on the simultaneous equation. Maybe going forward I may do a video on the simultaneous equation, but this is a calculator trick. So we can use the simultaneous equation to find the x and y, that is the unknown variables. Nonetheless, we can also use the Cramer's rule, because maybe for 3 by 3 you may be confused. And for simultaneous equation, note that this one, the calculator helped us to do it, but when you are solving it on your answer booklet, or in your answer booklet, you have to show working. So now, quick one, this is not a time for me to show working for the simultaneous equation. You can go and learn it on your own, or when the video is out for simultaneous equation, you can also watch that one out. So if you've not subscribed, kindly subscribe and hit the notification button so that when the video comes, you see. We are going to look at the Cramer's rule. So I said the Cramer's rule makes use of the determinants. The Cramer's rule makes use of determinants.